Password security is great. Even better if you can outsource the password management to OpenID or something like that. But I know that's not always possible, but it's nice. And if you're working in a business-to-business environment, things like the Windows Identity Foundation, Active Directory Federation services, using SAML tokens for exchanging privileges is really, really nice, and it means that you're never aware of other people's passwords. You don't have to have it, but you can still authenticate people from outside of your trust boundary by establishing trust through certificates. Finally, the last three vulnerabilities: failure to restrict URL access. Adding is admin equals true parameter on the end of the URL. Having a special URL for an administrative site that no one will ever get to because it's never rendered on a menu, right? That's very popular. That's great, but if anyone's ever used Backtrack, which is a penetration testing tool, they have this list in there that it will automatically try thousands upon thousands of different combinations that have been found from the wild of, admin.asp, adminpage.aspx, and it'll just roll through them and do its best and give you this nice report of, hey, here's the admin page for this particular application. And if it's not secured, because the developer says no one will ever get to it because I never show them the URL, so why do I need to bother to write this this authorization code at the top of every single page when they're never going to get to it? There's your vulnerability there. Insecure transport layer, SSL, we talked a bit about that when we talked about session state cookies and the fact that everything should be over SSL. Everything should be over SSL, regardless. External, internal, yes? Thank you. Yes, it is TLS. Everything should be over secure transport layer. SSH is fine too. But even on your internal stuff, because there is going to be some disgruntled accounting clerk who's got Wireshark or something like that and is watching things go over the wire. It's even easier on your internal networks because you don't have to go and pay VeriSign or Komodo. You can set up your own certificate authority internally. If you're on Active Directory, it's dead easy, and by default, any machine that's joined to your domain will trust certs that are issued by your domain controller, so it makes it really, really nice for internal stuff. The major thing is, like I said, if your session cookies are not set as requiring secure transport, and you may have HTTPS on your login form, but then you send them off to a summary page, and that's over HTTP, and you do any sort of rendering of, hey, welcome back, Fred. The reason that the server knew to call him Fred was because it had that session cookie, and it's now rendered over clear text back to the user, and anyone who's in the middle can see it. So secure transport for everything. The final vulnerability on our top 10 is invalid redirects. Not so much a security vulnerability, but more of a trust and reputation idea. If you're redirecting to partner sites, if you're redirecting off to other things, and you don't have a whitelist, I can take advantage of it and make it look like you are endorsing me, even when you're not, by passing an URL that's going to bounce through your site, and it's going to say, hey, welcome to Contoso here, go check out EvilCo. They're an awesome partner of ours. Please give them your credit card. Well, you've just vouched for me because you redirected that user off to me through you, and they think that there is something there when there in fact may not be. So if you are providing any sort of redirection, make sure that you're doing it off of a whitelist or being very, very careful about it. Mobile applications are also at risk. A lot of Mobile applications are being written by web developers who forget that the user is in control of that device. If I'm in control of it, I have access to its memory. I can see everything that's going on. OWASP is building what they're calling the top 10 mobile risks. Most of them are the same classes of vulnerabilities as we get on websites, but there are things like insecure data storage, not encrypting data correctly on the client so that other processes can get in and read banking information or whatever. The biggest things that are out there are crypto and session related, and there have been people who are actually watching traffic coming off of their iOS applications for banking that are passing account numbers in clear text over the wire, and the backend services don't have any sort of authentication on them other than accepting the account number. So if you find that URL, you can start making banking transactions just by seeing what the traffic is coming from those devices. So there's a whole world of mobile risks that developers also need to be aware of. Okay, we now have all of these ways of people attacking us. How do we make these unknown unknowns into knowns? There's a great way that I've found very useful. It's called building a threat model. It's the game board for our security. Not to be a Microsoft shill, but their security department is top-notch. Their security development lifecycle documentation is outstanding. It's a really great way for developers in general, and especially native code and managed code developers, to learn about how to build secure software. They have released this threat model tool where I can take it and basically you plot out your application, all of your inputs, your outputs, where your boundaries are. And I've got this simple little, whoops, that's not it. That's the wrong threat modeling tool. I think, unless they updated it. That's not the right one. Well, all right. I can't find the right, I might not have the right one installed on here, but you'll see as our schematic of we've got a simple web-based application. There's a web application. We've got our requests and responses, talks to the database. We also have an iOS application that goes through a set of data services and talks to the database. With the threat modeling tool, it lets us, forces us to document all the data flows in our application stack, makes us think about where our vulnerabilities are, also gives us some great material for bringing new developers on board because they can look at it and say, oh, here's where this is, here's where that is. And there's analysis built into it that makes you stop and think about the 6 different threats that that the areas of your application could be vulnerable to. Spoofing, someone passing information off as someone else, tampering, altering the data on the wire, repudiation, how do we know that it actually came from Bob and not from Fred, information disclosure, leaking of information, denial of service, elevation of privilege. So it's a great way of actually building that out, giving us some living documentation, and making the developers stop and think and take off their rose-colored glasses for a bit. So ways to find out what you don't know: security blogs, the security development lifecycle from Microsoft. If you don't like Microsoft, there's BSIM, Building Security and Maturity Model 3. That is a collaboration by another number of other industry groups who are doing something similar to the security development lifecycle, ways of documenting how to build secure code and what you should and shouldn't do in applications. In summary, input is evil. Don't ever trust any input. That will go a long way towards protecting you. And as with anything, you're never, ever completely secure. All you can do is make yourself as small a target as possible. And with application vulnerabilities, this is doubly true. The majority of attacks anymore are not coming from people who are targeting you specifically. They're coming from automated vulnerability scanners that scan every IP address and every port repeatedly, look and probe for vulnerabilities automatically. They probe for SQL injection. They probe for cross-site scripting. They probe for canonicalization attacks. Why? They want an inroad into your box, not because of what you have on it, but just because of what it is. They want to use it to send spam. They want to use it to deliver viruses. It's nothing personal. It's just their business, and they're going to take advantage of any vulnerabilities that you have. And it doesn't matter if you're a Fortune 100 company or if it's your kid's little league baseball roster. If it's got a vulnerability, these tools are going to find it, and they're going to do their best to exploit it for their own purposes. All the photos are Creative Commons. I'm not that good of a photographer. I give credit where credit is due. Like I said, for references, Troy Hunt, awesome resource. His free ebook that came out a few years ago now. OWASP.org, the Microsoft Security Development Lifecycle Center, the BSIM people. Writing Secure Code is an outstanding book, even though it's very, very native. And we'll have these slides up too. So, and with that, some of the tools, Web Protection Library, Backtrack Linux is a really fun tool. It's a penetration testing tool. It's a Linux distro in an ISO. You boot it up in a virtual machine, and you can probe applications to your heart's content. It looks for cross-site scripting. It looks for SQL injection. It looks for cross-site request forgery. It will exercise your applications to no end. And it's not that hard to use. Even developers can use it. I used a partly customized version of webgoat.net for this particular demo. And any questions? Yes?
You were talking about mobile.
Yes.
Do you know how secure Google's their application Google Wallet?
Google Wallet, I don't know in particular how secure Google Wallet is. I give Google major kudos for their two-factor authentication implementation. That is a really, really solid two-factor authentication. It's not that stupid that a lot of banks are doing of, oh, here, identify this picture. That's not two-factor. That's nothing. That's, you know, if I can cross-site script your site or whatever, I can show the same damn picture. But Google's two-factor authentication, I love it, and I love the fact that they do the fallback all the way to you can print out a PDF of emergency passwords and carry them around in your wallet. But yeah, as to the Google Wallet, I have no knowledge. I'm not aware of any significant vulnerabilities in it, but that doesn't mean that there aren't some. Yes?
I don't know if this runs through this, but I'll just ask you. I heard about a program that can save all of my passwords, and then I can regenerate passwords that are 18 characters and hard to crack and everything like that.
Right, so
LastPass.
LastPass is one. I use Password Safe. There are a lot of programs out there for managing passwords because that is one thing. You should never, ever reuse passwords because if you use the same password that you use on LinkedIn, that you use on Yahoo, that you use as your domain login, you know, the weakest link in the chain is going to expose that password. Password Safe. Yes.
And that's an application you put on your PC.
That is an application that runs on my Windows PC, and my Android tablet, because there's an Android version, it's got a database that's encrypted that there's a master password that I use to decrypt the database. And what I do is I keep that database on my Dropbox account.
I never access it unless I'm at my local machine, which is why I stopped using it.
Right.
That's a great way around it.
Yeah, and the reason I use password safe is I used it long before LastPass came out, and was originally written by a really respected crypto and security guy, Bruce Schneier, and it uses his Blowfish encryption algorithm for its database. So I don't put sensitive information on Dropbox unencrypted because I've seen some suspicious things on Dropbox, and the fact that they claim everything is unique, and yet they must, if you watch their bandwidth usage, they must be hashing files and not storing redundant copies. So if there's anything that I'm particularly worried about that I still want to share between machines, I'll put it on Dropbox, but I'll encrypt it first. So then, the only holder of those keys is me.
What was the name of that open source encryption that you're using? I've been using TrueCrypt.
Well, if I'm going to, like I said, my password safe database is encrypted with Blowfish because that's what password safe uses. Sometimes I use TrueCrypt for my boot volumes and making encrypted file system volumes. But usually if I'm going to encrypt something, I've got a little program that I wrote that I'll just AES encrypt the entire file, and I have the encryption key stored in password safe. So,
Gee, aren't you going against your own advice?
am I going against my own advice for? No, I'm not. I didn't write the encryption. I'm using AES encryption. I'm also generating a unique long password through password safe's functionality to generate like a 20-character password that I then hash for the full encryption key, and I only use that encryption key for that instance of the file. I don't encrypt another file with the same encryption key. So I try really hard to use the encryption the right way, and that's why I have a whole nother talk. SQL Server's got some really great encryption primitives built into it for cell level encryption, and it does things the right way too. And it makes sure that it uses a unique initialization vector as a nonce for every single time it encrypts a piece of data and sticks it into that column. But that's a whole nother hour and a half that we don't need to get into today. but yeah, it is really hard to use crypto right. Yes?
Just curious, didn't seem too keen on using PHP as a web framework?
I am not a PHP expert. PHP is very, very popular. People who write native, just plain PHP tend, in my experience, to take a lot of shortcuts. Some of the frameworks that are out there, Magento, WordPress, things like that give you some structure, and some of the more, I don't know a lot of the actual MVC style frameworks for PHP, but those that give you more than just the base language give you some structure and some good libraries to build on. But a lot of the PHP that I've seen is just hack together PHP, string concatenation everywhere. Let's just get the job done and ship it, and not using a professional quality library to build on top of to get some of that security built in. So I've also seen my share of crappy ASP code, of crappy ASP.NET code, of crappy C++ code. You can write insecure software in any language, just like you can write very secure stuff in any language. So.
You could give a sarcastic version of your talk where you just how to write insecure code on any platform. That'd be pretty good.
That would be fun.
I'd come see that.
Well, that's kind of what WebGoat is too, is some insecure code. And there's implementations of WebGoat for PHP, for Java, and I think for Ruby, or they're working on one for Ruby and Python. So yeah, it is possible to write insecure code in any platform. Okay, well, thank you for coming. I appreciate it.
We're going to go ahead and take a 10-minute break, and then we'll